Hey everybody, this video is here to help you out with getting started with our next task here. For this one, we're going to start to connect this form of a rational function with the end behavior, as well as what the degree of the numerator and denominator of our original rational function might tell us about the end behavior. So to do this, first we need to look at this rational function and decide what the degree is. Well, in this one, there is no exponent because there is no variable x. So with that in mind, the degree of the numerator here, 5, technically there's a 0x. The degree is 0. Whereas here in the denominator, the highest exponent on the variable x is 1. So the degree, the denominator is 1. 0 and 1 there. Now we need to rewrite it in this form, q of x plus r of x divided by b of x. Well, this one's kind of weird. Since the degree of the numerator is greater than the degree of the denominator, it's like we're dividing a smaller number by a bigger number. A quick example of that would be like dividing 5 by 12. Well, if we were to set up long division for that, 5 divided by 12, well, we know 12 goes into 5 0 times. And then we're going to have like some decimal amount here. But really, the quotient is 0, and then we'll have like a remainder at the end. 0 times 12 is 0. Subtract 5. So this is 0 with a remainder of 5 out of 12. So this is like 0 plus 5 over 12, which is pretty much the same thing as what we started with. In our case, let's look at this with a rational function here. We could do this with long division, or we could set up an area model diagram. Well, I want to see how many times x plus 2 goes into, like, actually that's negative 5. This negative 5 right here. Problem is, well, x plus 2 is a bigger number than negative 5. It's not going to go into that. Well, what we can do is add like a placeholder here. 0x. Well, I know that x goes into 0x. 0 times x is 0x. And 0 times 2 is 0. Subtract both. Negative 5 minus 0 is still negative 5. So this is 0 plus negative 5 over 2. Or over 12. Not over 12, over x plus 2. So this is really not changed. In fact, I didn't even need to do the long division here. In any case here where we have the numerator greater than the denominator's degree, all we have to do is just add a 0 in front. We know the quotient's going to be 0. So our form is 0 plus negative 5 over x plus 2. Having that 0 there is important. It's going to reveal some stuff for us later on. So now next what I want us to do is graph this in Desmos. Let me delete this random one I had from a while ago. All right, so if we graph the original function, negative 5 divided by x plus 2, it ends up looking like this. What I also want us to do is graph the remainder. The remainder we had was negative 5. Is that right? Or sorry, not the remainder, graph the quotient. The quotient is 0. And I'm going to make it a dashed line. We can kind of see that dashed line right there. Well, as we look at this now, the last thing we need to look at after you screenshot this graph and put it into, doesn't look like it's going to let me screenshot it. Yeah, it is actually. Quick screenshot, insert it into this Jamboard right here. Is the end behavior. Well, as I look at this, as x gets larger and larger and larger, the graph seems to be getting closer and closer to, well, 0. So I can write a statement. As x goes towards infinity, The function, which is called g of x in this case, goes towards 0. On the other hand, as x gets larger and larger in the negative direction, the function's also getting closer and closer to 0. So as x goes towards negative infinity, the function is also going towards 0. We have a statement for end behavior here. You're going to continue to do this for all of these different rational functions here. Once you have gone through all of those, on frame 10 here, or 9, there's a question here asking you to look for connections between them. And that's your task for today. This will be due to tomorrow as well as the assignment you were assigned yesterday. All right, good luck. Let me know if you have any questions.